Hello everyone, my name is Carl. Welcome to my workshop and welcome again to my YouTube channel. Well, this is going to be Rover gas turbine number 13. Can you believe it? We've really gone for it this time I've been at home. So in this one, it's a bit of a mixed bag really. We look at some more work on the Rotax actuator. I get the filler done. Unfortunately, it hasn't hardened in time. We have some electrical work. We have a component arrive, which kind of throws me off kilter a little bit, and I'll do some work on that. I say some work, just a bit of a test really, and a bit of a play with it. And you'll see what that is. And I do some work on the fuel system in terms of looking at the LP fuel filter. And I also take the ender probe and have a look inside the fuel pump on the engine. So without further ado, let's get on with it. So following on from last night's film, it was last night, chronologically speaking, I cleaned up the last of the carcass parts, and basically I did these in hot soapy water with Scotch-Brite and a pick. And also this little stainless steel wire brush that I, or Parkside stainless steel wire brush that I waxed lyrical about. I got 3 of these and they were 99 pence for the set. This has been worth 99 pence by itself, and it's already paid for itself in the short time I've had it, so that's good. So yeah, these are all cleaned up now. I've left the paint on that because it's pretty, it doesn't really want to come off, but we'll just put the primer over the top of that. That's the main body of the carcass. That's all clean now. That needs painting. And this, of course, was never... it was always onto a loser really in terms of galvanic corrosion, because this is ferrous, and of course it has to be because this forms the pull pieces of the field magnets when the field coils are energized. So I'll show you how this goes together. Somebody was saying, I think it was Peter, said in the comments, it was great to see the engineering of this thing and how it could all be dismantled into its component parts. So basically that is the output flange itself, where the drive shaft comes out of. So that's the foundation element, if you like, of the whole thing. That is where the plate goes for the micro switches. So that sits on top of there like that. Then you've got these 2 bronze stub shafts that are for the gears, and the bronze bearing. There's another one in there and another one in there. So that sits on there. This is obviously the carcass portion where the pinion comes out of. And these 2 shafts fit in those holes, so that goes on there like that. Then the armature portion, the field portion goes on with this little slot there sitting in the peg or the dowel. Then all the gubbins goes in there, and then finally the cover screws on and the locking ring gets fitted into that. And then of course we've got the breeze plug on this end. I don't know if I'm going to reuse that breeze plug. I might do, but there's lots of different types of connector that could go in there, so I'll have a think about that and see what I'm going to do with it. What I'm going to do now is try and have a look through my stock of micro switches and see if I can see anything or find anything that we'll be able to use for the limit switches in there. Right, I'm going to have a go with this putty. So from what I can tell, it's 1-to-1 mixture ratio, and you knead it together. Don't attempt anything without the gloves though, because it is quite dodgy stuff. So you knead it together. And it's almost, I suppose, got the consistency of plasticine really. When I bought this, I realised after I'd got it that I had some milliput, but I think milliput is more for ceramics rather than metal. This stuff's a metal. It's cheapo stuff. I'm hoping it's going to be alright and that we'll be able to machine it and stuff, but if not, we'll just have to dig it out and get some different stuff. And it's going a kind of a lighter grey, because the white, I don't know which one's the harder and which one's the... I'm assuming the grey one is the is the putty, and the white stuff is the hardener. But you know, I stand to be corrected. Right, that looks to me as if that's reasonably well mixed up now. So, right, let's see what we can do with this then. So I'm guessing the best way to do it is just to pack it in there. Like that, and try and get it to flow into the gaps. Then try and use this Stanley blade to squish it. It's a technical term, by the way, that squish. I don't know if you can see what I'm doing. I'm trying to spread it into the gaps. And I'll push it into the side there. I've been dreading this because I'm terrible at doing things like this. So yeah, you can imagine when I was doing the filling on the mill, oh my goodness, what a state I was in doing that job. I don't know though, that's not worked too badly actually. Squish it down a bit more. Just stuff a bit in the corner, in the edge there. The corner, it's a circle, you idiot. How can it have a corner? Right, I'll push that in there. I think that's pretty good actually. I was taking a bit out. Stick a bit more in there, look. Right, so you get the idea. I'll bring you back when I've finished. Probably about right. So I'm relatively happy with the outcome. That's post-filled with the aluminium putty. So haven't got a great deal to machine off. What I did was I kind of pushed it in to the pits, and almost I was scraping across the top of the pit as I was doing so. So it was kind of finding its own level, if you like. I've left it a little bit proud, not too much proud, because I don't know what this stuff's going to be like, and I don't want when the tool hits it in the lathe to knock it out. I might actually just put it in the lathe and just use emery paper on it to smooth it down actually, rather than using a lathe tool. The edges have worked pretty well as well. I'll try and zoom in on it. It's not easy to for you to see that, is it? Is it focused? Kind of. Yeah, so you can see the edges, look, they're not too bad either. I'll rotate it round. I kind of pushed it in with using a Stanley knife blade as a tool to really press it into the edges, and then as it rises up at the top, fold that over and squeeze it back into the pits. So hopefully when that goes off, it'll either machine back or sand back to a nice profile. So whilst we're waiting for this stuff to go off, we'll crack on with something else. I've actually wanted to take the fuel filter, the LP fuel filter, apart for a while. I did talk about it when I was at the museum the day that we stripped down the nacelle. So we'll get that in the vise and have a look at it, because it's been open to the atmosphere. So judging by the condition of this thing, goodness knows what it'll be like inside, because I don't think it's going to have any fuel in it. Right, we'll get on with it. Right, so here it is, the LP fuel filter. And you might have heard me call this, when we were working on the nacelle, the purulator. And that is a really good example of that scenario that we get ourselves into, where people use a trade name to mean an object. So for example, Hoover for vacuum cleaner. So these were made by Purulator. The other thing is that they were called micronic, as in they filtered down to microns. And another thing in aviation, you'll hear people call a filter a Purulator. You'll also hear them say a micronic filter, and this is where it comes from. In fact, in the AP for the engine, the AAPU, it actually refers to the LP fuel filter as the Purulator. So there you are. it even crept into the standards. But I'll bring you in a bit closer to have a look at it, and then we'll start dismantling it. I was trying to say taking it apart, dismantling it. And I will be, I have to say, pleasantly surprised if there's no corrosion inside it. Having said that, the Lockheed Avery coupling here, which is a self-sealing coupling, so you could unscrew this from the engine and it wouldn't spill fuel out, and then you could take the whole engine out as a line replaceable unit. That doesn't have any corrosion on it, which is a good sign in my book, because these often get bitten into quite aggressively because they're mag alloy again, like the Actuator was. So I'll bring you in closer, then we'll start taking it apart. So I've zoomed in on the data plate so you can see it, and there you go. Look, it says Purelator Micronic in inverted commas, because that was their trade name. Registered trademark, as it says there. Fuel filter, serial number 0099, type number MFFA24200, element number MFFA242, AP Company Limited, that's AP Automotive Products. They make a lot of hydraulic components for aircraft, or yeah, I think they still do as well. And I believe they were up in Carlisle somewhere. So that element number, MFFA242, a quick Google search of that has come back kind of with a non-committal response. I think we'll be able to get an element for it relatively straightforwardly, so we'll take it apart now. Once we get it apart, we'll be able to get a number of the element that's inside it, assuming it has got one inside it, which we'll now find out. So the first thing I'm going to do is take this Lockheed Avery coupling off, and I have the ubiquitous empty takeaway carton ready for all the bits, and also just in case there's any fuel in it as well, which I don't think there will be. And I've got my favourite Facom C-spanner. So we'll just sever the locking wire first on this coupling, and we'll have a bit of a tutorial one day. I'll take you through what these things are all about, and it's one of the things I intend to do is to a lot of people won't be familiar with a lot of these aircraft components and manufacturers and bits and pieces, so we'll have a bit of a teach-in while we're doing it. That's not going to work because it's too big. Right. I know what I can use on that. Yes, I know what I can use on that. Parkside to the rescue, yet again, I hope anyway. Let's see if this works. It doesn't work. Right, okay. I'll tell you what we'll do. Let's get medieval. I use my other grips with the tape around them. Yeah. See, I'm not sponsored by them. If it doesn't work, I'll tell you it doesn't work. I haven't got a small enough C-spanner. Or maybe I have, actually. I'll stop. Right. I'll bring you back when I've got the proper... Right, so 3, 2, 1, you're back in the room. I've got a smaller C-spanner. So let's just pretend that whole debacle with the grips didn't happen. Right, let's give it a try then. I don't think this one's... I think this one's going to be too big as well. But I'll put that a bit lower down in the vise, I think. You can still see it, can't you? Yes, you can. Right, let's try and get it on. Some of these are a bit mashed up, probably because somebody used the wrong size C-spanner on them. Ah, there it goes. It's given up the ghost. Ooh, that's making a funny noise, isn't it? Now, I bet you this is stuck open. It is, yeah, look. Yeah, I thought it would be. Okay, so Lockheed Avery coupling, that's one side of the coupling, which when that gets pressed in, it opens up. So that's the sleeve, obviously. This portion is where your BSP connection goes on, your AGS pipe. That fits inside there. I'll bring you in a bit closer and I'll show you this end. You can see there, look, this end is stuck open, but you can see how it works. There's holes in that. The fluid passes through there and down into whatever it's connected to. And that's quite common, that happens. You know, it's not surprising considering it's probably got corrosion inside there, or, you know, the spring's past its best. And one of the hydraulic ones, one of the ones for the hydraulic system that was on the nacelle on the outside was like that as well, if you remember. If you go back and look at that one, you'll see. So let's get this off of the actual filter body and we can see why it's stuck. So I just need to I'll cut this locking wire off. And it's got a locking tab, look, so that would have been on a bolt somewhere. So we'll save that. That'll be useful. We'll need that at some point. Believe it or not, that is an AGS component, so it has an AGS standard number, as does everything else. All the piece parts that are used on aeroplanes, or British aeroplanes. Just clean some dirt off that. Right, I suspect this has got a aluminium sealing washer in there, as opposed to a bonded seal. Right, I might struggle with this now, but we'll give it a go. It isn't ideal, but it might work if I shock it. Let's see. Did that go? Yes, it did. It's turning. Right, it's pretty solid though. Oh no, it's gone now. It's given up the ghost. Right, so that's that coming out. No fuel, which is good. Didn't expect there to be any really, but you never know. So yeah, AGS aluminium sealing washer. And there we go, there's the other portion. And that is well and truly stuck. But we should be able to free that off. Yeah, you can't see very well in there, but that's where the guts of it is in there. Right, can I see anything in there? Oh, it doesn't look too bad. I can't see any corrosion. So we'll get this sort of branch pipe off now. And you'll remember there was a banjo on there when it was in the nacelle. Get this locking wire off, which is locked to a tab on the filter itself. Everything aircraft is provided with ample anchor points for locking wire, and that'll be BSF. So let me have a look and see what we've got. I am going to say that is going to be 1/2 inch BSF. Look at that! Woohoo! So 1/2 inch BSF, which also is non-binary, and it also self-identifies as 7/16 Whitworth. Right. Oh, she's tight. Oh no, there we go, giving up the ghost. Again, we've got another sealing washer. So there we go. Sealing washer comes off there. Oh, it's just stuck on. I'll leave it on for now. So yeah, what did I say that was? 1/2 inch, 7/16 Whitworth, 1/2 inch BSF, and that will be a 1/2 inch BSP P thread. So AGS standards were way ahead of their time, because you've got a BSP P thread that self-identifies as a 1/2 inch BSF on the flats, and is also non-binary because it's also on some days 7/16 Whitworth. So yeah, well ahead of its time. Now I might as well have a look in there. It doesn't look too bad. Can't see any horribleness. I'll get this locking wire off and we'll get... I can't really see any reason to take this plug off. Whoa, flying. That'll be part of the bypass, I would think that. So we might take it out once we've got the filter element out. Right, let's tip this up in the vise, and let's just ensure that there isn't anything in there before we take the bowl off. Let's get I'm off camera, but I'm just getting or maybe I'm not, just getting a tub. Oh, I'm not off camera, look, I'm there. I'm still there. You can still see me. Now it's a bit mucky, this one, but it doesn't matter because it's just to catch any detritus, any liquids. Nah, there's nothing in there. Right. Put that back where it came from. Oh, it's making me feel sick looking in there. Horrible. That's all the crud that came off the milling machine, or some of it anyway. I think the Dutch would be interested in the crud that came off the milling machine because they could build their own country out of it. Use it for landfill or something. Right, how am I going to do this? So I reckon we'll hold it on one of these flats, or perhaps like that, against the that cap. Let's see. Yeah, I think that's going to be okay. Oh, no, it isn't. That's rubbish. Right, I'll do it like I said. Do it against the flats where the bolt went. Both bolts. Right, we'll cut this locking wire here now. And this one. Right, we may. Now this has got a nice square drive on the end of it for you to undo this, and astonishingly it's actually not been mullered, because a lot of the times they have. So let's find out what size that is. Probably be Whitworth, but it might not be. It might not be. No, I don't think it is. I'll tell you what, let's see if we can get an AF spanner on it. Still working out of the toolbox, but I can now put all my tools back. I just haven't got round to it yet. 13/16. No, that's too big. So we want 3/4, don't we? Yeah. Which I think is in the box. Oh, come on. Right, it's not funny, is it? I'm going to bring you back when I've found the spanner. I've got it held slightly differently in the vise now. It's across the flats where the inlet and outlet fittings were. So hopefully that'll hold it solid. So I just showed you how that's in the vise. Let's see if we can get any purchase on it now. Any Murray. And that is a joke. That's the wrong end, you div. And that is a joke. The innest of in-jokes that very, very few people will understand. Right. I'm going to hit it with my other favourite hammer. Shouldn't have favourites, should you really? They're all my children are equal in my eyes. I mean, these children. Right, come on, Carl. No. You know how we're saying people always muller the flat? Well, I've just mullered it. And I'm not very proud of that fact, but it'll survive. Right, what we need in there, my friends, is a substance known as plus gas. So maybe if I fill up the filter with it, or just run it in there, because it ain't coming off. And that means only one thing, corrosion. I've just said corrosion, but can you see that? Look. That's fuel. Definitely. You see the fuel, or it's some it's fuel mixed with some kind of inhibiting oil, maybe OM11, something like that. But there's definitely, oh, I can see corrosion. Yeah, I can see it. Yeah, I'll try and get you to see that actually. Right, that's what I was on about. I did think it might be corrosion, but I'm not so sure now. Now I see it with the light shining on it. But we'll try and get this thing apart and see if we can see anything else. Right, so let's get some of Grandad's Plus gas on it. It's definitely, you can see that straight away. Its surface tension is so low that it immediately goes in there. You can see it sinking in, seeping in rather. Right, I'm going to go for some lunch and I'm going to leave that to soak, and when I come back it's going to come off. It's going to come off there like a dream. I confidently predict. And I do have other options if it doesn't work. Heat is another one. I don't want to spend too long on that, to be honest with you, because one of the things, it's my last day today of working in the workshop before I go to work tomorrow, so I was hoping to be able to get the ender probe and look inside the engine a bit more and see if we can see anything else, because all this corrosion has now got me worried. Condensation inside the actuator could mean condensation in other places as well, and it may not have been inhibited perhaps as well as it could have been, or even at all. So yeah, I am a little bit concerned about things like the fuel pump and this type of thing. If there's corrosion in there, we're stuffed. Right, so I'll go for lunch, I'll come back, have another crack at it. If we can't budge it, we'll do something else. So I'm back, having had lunch, that is, and I've given up on the purulator or the LP filter for the time being. I got very medieval on it. I had the Stilson on it with a rag around it to try and stop it damaging it, and it just was not for budging. In fact, I was moving the whole workbench at one point when I was trying to whale on it. So I've put that to one side. I've currently got the buzzer warming up to 80 degrees, and then I'll put the filter in the buzzer and give it half an hour or an hour in there to take it up to 80 degrees as well, and see if that makes any difference, see if that busts it out. I haven't got like oxypropane or anything like that to warm it up with, or even a little torch. The only thing I've got is a heat gun, so I think I'll stick it in the buzzer for a bit and see if that makes any difference. Anyway, in the meantime, I've got the armature from the actuator, because it's the one thing I haven't checked really, not properly anyway. I only checked it through the brushes, which never gives you a proper indication. So I've cleaned this up with methylated spirits, and I've cleaned up the commutator. As you can see, it's nice and shiny. So it's a 5-bar commutator. And so what we're going to do now is do some checks on this armature through the commutator, just to make sure that it's okay, because we've checked everything else. Remember when we were doing the fault finding, we checked the field windings, and we also checked the brake pack. So I'll check bar to bar on this through the comm, and hopefully you can see the multimeter. So I'll just go around bar to bar until I've done 360. So that's 1 ohm there. Move round to the next ones. 1 ohm. Move round again. 1 ohm. 1 ohm, and this is us back at the start now. 1 ohm. So what I'll do now is 180 bar to bar, or near enough as I can get. Okay, so this is the first measurement. 1.5 ohm. 1.5 ohm. 1.5 ohm. 1.5 ohm, and this will be the last one. 1.5 ohm. Okay, so I don't know what they should be, but they're uniform and they sound about right. You know, that's what it should be, between 1 and 1.5 ohms. Nothing's open circuit. So I'm pretty happy with that. So we'll put that back in the box with all the nice clean parts. So there's one more thing I just want to quickly show you while we're on the subject of the actuator again. These are the micro switches that I want to use to replace the damaged or corroded limit switches in the unit. So I'll zoom in on it so you can see it. So these are very, very common things. I've got lots of them in my collection of electronic parts, and these are rated, as you can see there, look, 3 amps 250 volts AC. So the actuator maximum current is 2 amps, so these will be fine. So you've got it's an SPDT switch. You can also get them without this lever, so I might have to remove the lever or get some that don't have. I've actually got some somewhere, I just need to find them, that have just got the button. So the mounting centers on these are 9.5mm or 385 thou if you prefer, and the holes are about 2.3, which is about 85 thou. So that's 8BA essentially, which we can use to mount them with. 85 thou is about 8BA clearance. And the problem that we're going to have, well, it's not going to be a problem really, but we're going to sort it, is that you can see there, look, that countersunk hole was the one the bolt was through to mount the old switch to it. So this isn't going to line up. So we are going to have to drill new holes, and we might have to, if we look at the position of, that's where the other switch goes. So you can imagine the cam is poking out through this hole, look. So if we put that one there where it was, we're probably going to have to adjust the position of the switch in relation to where the cam is on the plate. So we may have to just drill some new holes or redesign it slightly. But you can see these are all enclosed, so that's a big improvement on the old ones. So the direction and the complexion of the video is going to change slightly now, because something has arrived which has changed what I've decided to do. I was talking about getting the ender probe out, but I might not have time for that now because something has turned up. This is something which I ordered from eBay, and now I've seen what the engineer's panel looked like in the Argosy, and it had a certain type of switch that was the starter button for the APU, the engine. The Nimrod had exactly the same type of switch, and this is it. I'll open it up in a minute and show you. So it was a magnetic switch. You push the button in, and it was held in by an internal solenoid, and that started the auto sequence start for the engine. And it would have been the same on the Argosy as well. And there was a phrase that was used when we used to do engine runs, and it was buttons in, buttons held. And I really, really wanted to have buttons in, buttons held when we start this engine. So I've managed to find one of these switches. I've got one. It's in great condition, so we'll open it up now and have a look at it. I said I don't do unboxing videos, but this is an unbagging video, so it's different, right? So you can see, look, it's sealed, it's vacuum sealed, it's got a green label, a serviceable label in it, so it's been in there for quite some time. It's going to be in great condition because it's in this bag and it's got that label in there because it's been maintained, it's been serviced. So let's open it up and we'll find out what it's like. So this is the first time this bag's been opened in a very long time, I would think. But let's see. We'll take out the switch and I'll show you it closely so you can see it. And these are made by, guess who? Yes, Rotax. And they were taken over by, guess who? Yes, Lucas Aerospace. So, I mean, it looks absolutely brand new. See there, look, Rotax, volts 28, serial number 2004. Let's get you closer in and have a look at it. So here it is, the erstwhile switch. Goodness knows when that was taken out of that bag. So, or when it was put in the bag, I should say. We've got a couple of 2BA nuts, look, attached to it. So it would come with those because this would be fitted in with studs that would already be in situ. So cut two 2BA nuts to fit it with. And they're on there with a bit of telltale wire, or enamelled wire, telltale wire as it's known in the aircraft industry. So it says switch D2214/1, volts 28, serial number 2004, Rotax Limited London, mod number, it doesn't have any. Oh no, it does, 28130 3138D. We've got a manufacturer's mark there, mark 1717. What does this say? 30th of October 1962. And that's illegible, I can't read what that says, but that's probably an inspector has put that on there. So the terminals are in this end, and it's this this terminal boot is secured by this knurled ring, which is secured in turn by this snap ring. So yeah, what a beautiful thing. Right, let's have a look at this label now and see what it says. Been in there a long time. So installation data, it's blank, so it hasn't been on anything. Safe Air Limited, it says, so that's obviously who it was refurbed by. Serviceable, Safe Air Limited, serviceable E3D, that must be their form number. Card number AZ13, description switch, part number D2214/1, 2004 serial number. Serviceable until date. It doesn't have inspector's signature. I wonder if he's still around, or she. 10 Safe Air. So that looks to me like it says 22/175. So the 22nd of January 1975, that's been in that bag for over 40 years. So I took the snap ring out of the knurled ring, threaded ring that holds the cable boot on, and it's got a grommet in it. It's just tin, or maybe even plastic actually. There's the terminals on the back. So we've got two there that have got kind of sister flex on them. They're for the solenoid, and the other two are for the switch. So we'll test the switch now. Hopefully you can see the multimeter. I've got it on, if you can't see it, you'll hear it, because I've got it on, excuse me, I have got it on continuity. So we'll go on to the switch terminals. So we have no continuity at the moment. I'll push down on the switch, and that should make it. Yeah, so there you go. It's showing about 30 ohms. So a bit more than I would have thought, but let's measure the resistance of the solenoid now. So we'll put it on 25 ohms, the solenoid. Right, so we'll give this a go. I think we'll connect the battery up to it, and we'll push it. We'll wire it up so that when we push the button, the switch makes the solenoid and it holds the button in. So we're going to do buttons in, buttons held. So this has, of course, been in a bag for 50 years. I can't do sums. Anyway, 50 years undisturbed, and there it is. Amazing. Blows my mind. So I haven't got the correct tool to remove these special slotted terminal nuts, but I have got this little pair of round nose pliers, and they are perfect. Because what I don't want to do, of course, is open up a switch that's been in a bag for 50 years and then immediately break it. Right, so I'll get all these off, I'll get some wires, and I'll bring you back when we're ready to test it. Right, I've connected the switch up so that the switch is in series with the solenoid. Now normally the solenoid would be released and would be held in by a relay or something that when you push this button it operates a relay that starts the sequence for starting the engine, and that relay also holds in the button, holds in the solenoid to keep the button in. And then when the engine started, the power is disconnected to the solenoid, so the button pops back out again. I've got the battery providing the power. So let's set you up on the vice so you can see what's going on. Now my friend Colin Gow, who used to be a flight engineer on the Nimrod, which had exactly the same switch as this for starting its APU, and it had a Rover APU, not the same one that we've got, but quite similar. It had this button, and we always used to say, as I've mentioned before, buttons in, buttons held. And my friend Colin said to me, Carl, are you going to have the button? And I said, do you know what, Colin? If I have the button, you get to push it the first time we start it. So it's not quite there yet. We've got a long way to go. But Carl, if you're watching, and I know you do sometimes look in, this is for you. Right, here we go. This is the moment of truth. Here we go. Right. Buttons in. Buttons held. Look at that. And then, there we go. One more time, eh? One more time. Let's get the wire back on the battery. Buttons in. Buttons held. So I'm removing this banjo connection from the fuel inlet on the pump, fuel pump. And there's definitely some fluid of some kind in there, because I saw a bit of a bubble then. So I'm going to put the ender probe inside there, and I'll show you what I can see. I don't know how well you're going to be able to see this. So I'll put the probe in, and what we're looking at there is, I would say that is the rotating group, because this is a swash plate type piston pump, and there's definitely some fluid in there, but you can see there looks to be some kind of corrosion in there as well. I don't know whether that's corrosion or just residue of dirt or what, but it looks like corrosion, doesn't it? As we go deeper in, try and keep it there because it kind of stays in focus. But it doesn't look very good. There's like a copper pipe or something down there, a little brass pipe. We'll have a look at the drawing in the AP and see if we can orientate ourselves to what that is that we're looking at there. So here's the cutaway drawing of the pump in the AP, and we had our ender probe down this hole here, look, through this port. So what we were looking at, what we must have been looking at, was the face of the pump rotor there, into which the pistons and the springs are fitted, and they're on a ball joint. And then you've got the slippers, the slipper pads, and the cam plate is integral with the end of the pump. It's just machined into it and it's fixed. So this is it's a swash, it's kind of a swash piston pump if you like, but it's fixed angle. So there's 3 of those pistons. This is the governor assembly, and the way the governor works is, you can see there, that's a valve on a seat, and as the centrifugal weights get thrown out by the pump rotating, the rotor spinning round, they overcome these springs and they spill fuel from the pumped region back into the case. And we've got this bleed screw here, and it's got this big fitting on it, and I wonder if we take that big hex off, we can get better access with the ender probe into the body of the pump, because I would like to see what that's like inside there. Looking, we could look down this drilling here, and there was definitely fluid, fuel or something in there. So I didn't have the right size spanner for this. It is Whitworth, but I didn't have one. But we're using another one of my granddad's tools, his big old adjustable spanner, and this is a proper old school adjustable. My granddad used to call this a knuckle breaker, and if you've ever tried to undo a bolt with it that's really, really stiff, you'll know why it's called that. So oh, that's pretty loose, eh? Right, so that's done the job. Let's get that out and have a look inside. So that's that plug out that's got the bleed screw on it. It definitely smells fuely. We'll get the probe inside there and see what we can. So I'll put the probe in, the camera. The first thing that we see immediately is one of the slipper pads, one of the pistons protruding from the rotor there. Can you see it? It doesn't look too bad. I'll move the probe and see if we can see anything else. Right, so what that is one of the governors, governor assemblies, and you can see there the bit that the sort of the valve that spills the fuel into the casing. I'll try and show you that inside there actually without the probe, because you might see with the camera. But corrosion wise, I'm not sure that that is corrosion. It might just be dirt. And it is quite fuely in there, so there's no fuel in there, but it is quite wet with fuel, and it does smell quite fuely. So that's not a bad... So there you go, that's looking inside the pump. And that thing that we're looking at there, I believe, is part of one of the governors. I don't know which one it is, whether it's the high speed or the low speed, but that's definitely a part of one of the governors. Right guys, that's the end of another one. Thank you very much for watching. And it really is the end this time. I've got to go to work tomorrow, unfortunately, so there'll be no more videos from me for the next few weeks. What did I get done today? A few postscripts for you. The filler on the flange from the rotor actuator has hardened now, but I don't have time to finish that off, so that'll be waiting for me when I get back home. The primer, the etch primer, turned up today or this evening while I was having my dinner, so again, obviously that's going to be waiting here for me when I get home. The filter, the LP filter, that went into the buzzer, but it did it no good whatsoever. It still didn't come undone, so that's another job to do, but that's on the back burner now, really. And the great thing about this switch, I need to tell you this. So we tested the switch today, this starter button. Now, Safe Air, it says on the green label. So I looked up Safe Air. I couldn't find a company in the UK called Safe Air Limited. It turns out that in New Zealand there is a company called Safe Air, and that stands for Straits Air Freight Express. I'm just looking at it where I've written it on the board there. Straits Air Freight Express had quite a large maintenance side to their business. They did a lot of aircraft maintenance and bay maintenance on components. They also ran the Argosy civilian version in their fleet. So I may well have bought an actual Argosy APU starter button. So we've got an Argosy APU sitting down there that I bought off eBay. I had the manual, the AP off eBay as well, that came up at the same time as it. I've now gone and bought, unwittingly, an APU starter button from an Argosy. So it's all coming together, people. You know, it's all meant to happen. So yes, that's really good. The other thing I wanted to say to you was that looking at that fuel pump today, I think it's going to have a change of priorities when I get back for the way that I'm working on the engine. At the moment, I've just been kind of skirting around the outside of it on the periphery with you know, things like the generator and the actuator and things like that. I think I'm going to have to get into the meat of it when I get back and start stripping the engine down and looking at all the major components, because there did seem to be what might have been corrosion in that pump, in that fuel pump. So we need to look at that and try and solve it. The other thing I saw when I looked at the compressor rotor, there looked to be some pitting and some corrosion on the compressor rotor. So we need to check that out as well, because if material gets lost off the rotor by corrosion, then it goes the shaft, the LP, the compressor and the turbine shaft together as an assembly, that will start to go out of balance, out of limits for balance. So that is something that we do need to check on. So anyway, that's the end of the video. As I said, thank you very much for watching. Thank you very much for subscribing. If you're not subscribed, please do join us, join our gang. I'd love to have you along for the engine and the mill projects. That would be great. And please do give me a like. It really helps to boost me up with YouTube. Seems to appease the old gods of YouTube for some reason. I don't know why, but there you go. Anyway, thanks very much, everyone, and I'll see you when I get back. Bye for now. Take care of yourselves.